Hello, and in this video we're going to look at 3.03 intersection of graphs. Alright, so we've talked about solving for when two graphs intersect. So you can also solve the equation f of x equals g of x by graphing f of x and g of x on the same coordinate plane and see where they intersect. Okay, so this is pretty much what we've been doing. And so you graph it. And once you graph those two functions, then you're going to see the points where they intersect. So the points of intersection would be, let's say we got 0.5, 2, and we have 2.5. Okay, so those are the 2 points where the two graphs intersect. Alright, so you can graph these in Desmos. So keep in mind, solve the equation f of x equals g of x by graphing. So you're going to put this in Desmos and you're going to see those 2 points of intersection. So you just double click on those 2 points and it shows you where they intersect. Okay, so in this case, your solutions will be the point 1, 2, and you have to write them as a point with parentheses. So in your other point, negative 3, negative 2, is your other point. So you have 2 solutions at these 2 points. Okay, so now I want you to try this one. So I want you to pause this video. Okay, I want you to pause this video and find the point or points of intersection between this straight line and the curve. All right, now that you have had a moment to look at this one and find the point of intersection of the straight line, so you need to plug it into Desmos and you're going to see that it intersects at the point 7, 3. Okay, so it only intersects at the point 7, 3 only. All right, so here's another way you can solve these. You can use a table. So this is an example where you're solving f of x equals g of x using a table. Now you can also plug these in Desmos. Okay, keep in mind you can always use Desmos, plug them in there, get your 2 points. Okay, so when you are looking at these, you're looking at your x coordinates. Okay, you have x coordinates, you have y coordinates. So you're going to look at the places where they are the same. So for example, right here, so you have the point negative 2, 3 in common. So you look at the places where they intersect and they are the same. And then you have the point 2, 1. Okay? And that looks like that's all the points of intersection. So the equation f of x equals g of x has 2 solutions. Find the solutions on the table. So anytime you're using a table, again, you just figure out where you have the same points in common, which means they intersect at those same points. So here's another example. So I would encourage you to pause this video for a few minutes and find the points where you have solutions. Find the points you have in common. Okay, so hopefully you pause this video and look at the places where you have the same x and y coordinates. So there's the first one. So it looks like you've got negative 2, 3 as your first point, and nothing else. So you've only got, well, it says you've got 2 solutions. You do not have 2 solutions. You only have that one solution. Now you could also plug it into Desmos and double check and see if you have another one. Okay, so since it says you have 2 solutions, I only see 1 on this table. So I would encourage you to plug it into Desmos and see if you have another one. Okay, that's why I like the Desmos, because you're not limited to what's on the table. Okay, so plug that into Desmos and see if you have another one. Okay. All right, so let's look at the application. Now, where are we going to use this? So here's just an example. The rental price for an apartment in an apartment complex is given by R of A equals ln of A minus 2 plus 8, where A is the number of apartments rented And R of A is the price in hundreds of dollars that the landlord could charge. So then you have the function WA, and that's negative A plus 18, represents the amount of money that the renters are willing to pay. So explain how to determine how many apartments will be rented when both the landlord and the tenant are happy with the rent charges. So we're going to find the point of intersection. Looks like it's right here. Okay, so we have 8, 10. Now, what does that mean? What does that mean? So when they intersect at one point, so and that point is 8, 10, when 8 apartments are rented, okay, this means when 8 apartments are rented, both the landlord and the tenant are happy with the rent charged, okay? Now, the X value of the point of the intersection is the number of apartments rented when both the landlord and the tenant are happy with the cost of rent. Okay, so that's how you would explain this. That point of intersection means that's where both the tenant and the landlord are happy. All right, so the application of the intersection, here's another one. So we have a graphic artist is working on a cartoon in which the path of a devious bird will follow the curve modeled by an equation. So you've got the equation there from left to right, okay? And that is the that's the red curvy one. At the same time, a screaming golf ball will be followed by the same modeled path. So you have the other equation represents the golf ball. So the scene will take place in the first quadrant, okay, which is the positive quadrant, with the bird catching the golf ball when the ball is falling back to the ground. Okay, so that's when the ball is falling back to the ground. So that's going to be, let's see, let me get a little yellow one. So that's going to be this side right here. Okay, that's that side right there. Because remember, the golf ball is going up and then it comes back down. Okay? All right, so the scene will take place in the first quadrant where the ball is falling to the ground. We got that? Okay. So what are the coordinates of the point where the bird catches the ball? All right, well, it looks like it's going to be that one because that's where the ball is falling back to the ground. So the bird is going to catch the ball at that point. So round the coordinates to the nearest thousandths. Okay? So thousandths mean 3 places after the decimal. So that's what we get in decimals. So we have the point. Write it in a darker color. So that is the point 9.879 21198. 21.198. Okay? So at that point, that is where the bird is going to catch the golf ball as it falls back down. All right, so now it's time for your ticket out the door password. This is for your ticket out the door linear and quadratic systems. So your password is capital D, lowercase a, and the number 5. So that's capital D, lowercase a, and the number 5. And again, here's our calendar for this week. So don't forget, we did 3.02 and 3.03 today. And you do have this ticket out the door you need to complete. Wednesday, you'll have 3.04 quiz, and Friday, we have another ticket out the door. All right, so keep in mind, today you need to complete 3.02, 3.03. The lessons, you need to complete the lessons. The quizzes are not required, but I still encourage you to do them. So you need to complete those lessons in the OHS and complete your ticket out the door. So let me know if you have any questions.